Hola, boa tarde. My name is Vincent Stélé. I'm working at ARM on SystemReady, and with the community, we are maintaining the EBBR specification. I'm very happy to be here at the Linaro Connect in Lisbon with you, and I'm glad that we can finally have a session on a birds of a feather session on around EBBR. So welcome. And with that, we can have a look at the agenda for today's session. First, I'd like to do a quick overview of EBBR so that everybody in the room is on the same page. If you're an EBBR contributor or if a newcomer to EBBR, you should have some basic understanding after that. Then hopefully we can have an open discussion with many new ideas coming from you. And if time permits, we'll see UEFI HTTPS boot demonstration. Let's begin the EBBR overview. So what are we trying to solve with EBBR? We are coming from the embedded ecosystem on ARM platforms, which is very diverse, very rich, very successful, but also using very different boot methods from system to system, very customized boot paths, and we certainly don't want to prevent that. But we want to enable this new use case of standard off-the-shelf distributions booting on all those systems. And sometimes the diversity in the boot methods is preventing that or would necessitate much custom development. So we need a new standard path to boot those distros on the systems. On the server side, this has been solved with UEFI and ACPI, but for the embedded systems, it's sometimes deemed too heavy, too complex, and also in many cases that would necessitate dropping completely the existing software to replace it with a new ACPI UEFI capable firmware, which is maybe not preferable. So we need something new. And that's where the EBBR specification fits in. So this specification defines the interface between the system and the operating system, and this is largely leveraging the UEFI interface, but only a small UEFI subset, which is sufficient to boot the OS, and this is what is actually thinly drawn in the EBBR specification, and also a few other interfaces between the system firmware and the OS. This specification is largely an agnostic specification in that it is not specific to an operating system. It is largely agnostic to the platform firmware description. It can be ACPI or Devicetree, even though it is well known that in the ARM SystemReady program, we are relying only on Devicetree for embedded systems. The EBBR specification itself is agnostic with regard to that aspect. We are also agnostic even to the architecture. This is probably lesser known in the ARM context, but this is the case in the EBBR specification actually. And we focus on the interfaces and not the implementation, meaning that we are agnostic actually to the bootloader. It can be U-boot, it can be EDK2, it can be something else. And last but not least, this is a community-driven specification. More than 30 people have participated in the elaboration of the specification as it is now. And we are driving it largely based on the consensus for the evolutions. And anybody can participate, basically. So with that, let's see how well this is supported now. So what we are seeing here is the EBBR support in terms of operating system on the left, in terms of bootloaders and example systems, which is far from complete, but example systems. So in terms of OS, you'll notice we have a number of Linux distributions which are capable of booting on EBBR compliant systems. The Debian and Ubuntu family, Fedora, Red Hat families, OpenSUSE, and more recently we have Yocto and OpenWRT producing generic images capable of booting on EBBR systems. So not shown here, but we also have the trusted substrate distribution produced by Linaro, which is compliant by design, of course. And also lesser known, a few BSD distributions, such as FreeBSD and NetBSD, can boot on simulator on EBBR capable systems, well, simulators in that case, but also on at least the Rock Pro 64, which is hardware system. So in terms of bootloaders, on ARM side, this is mostly U-boot we are seeing on that type of systems, but as we said, this is not mandatory. And as per the example systems, also, as I'm working on ARM side, I'm more familiar with the ARM-based systems shown here, which are the ones which were certified in the SystemReady certification program for IR2 last year, basically. So those are the most recent systems we know of, if you want. Of course, not shown here, but worth considering are the systems which are currently in the Linaro One Lab undergoing continuous verification of the firmware. So those systems are also EBBR compliant by design. And we heard also that the liberal computer type of system claim compliance with the EBBR certification. So even if we could not verify that, this is what we heard. Okay, so nowadays the EBBR the EBBR specification is fairly well supported, so it's not that difficult to start fiddling with those system bootloaders, have a look how it works. So now is a good time to get involved if you want. And that's here are some pointers for you to reach out to the EBBR related people, maintainers, developers. The starting point would be the GitHub website, I think, for looking at the latest version of the sources, grabbing releases, and also looking at the wiki for meeting notes, pointers, etc. If you want to participate or if you have a question, you could start sending an email to the mailing list, for example, or you could simply join one of the regular calls if your time zone allows it, because this is on UK time zone. Okay, I have one last slide before we move on to the open discussion, which is about the overview of the past and present EBBR releases. Version 05 was done by Grant Likely in 2018, a while ago. We've come a long way since. We are at version 2.3, which was released in 2024. It was mainly adding the UFI boot manager requirements for EBBR compliant systems, also a few additions. And on the branch right now, we have unreleased modifications about the graphics output protocol recommendation and ARM-specific FFA additions, which are visible by the OS. And under discussion, we have addition regarding SCMI, which is also visible by the OS, and discussion on the runtime services. And that concludes our overview of EBBR. And I think we can jump into the open discussion. So this discussion is by no means pre-constrained or prepared, so I'm counting on you bring your ideas, your question, anything you want to discuss around EBBR. So I've thrown here a few keywords on the Azuleros. If you're not inspired, for example, you could pick any keyword and we could debate around those. But I think to kick off the open discussion, we might as well do a roundtable and maybe pass the mic so that everybody can introduce himself, tell us where you come from in terms of EBBR, so what is your experience in EBBR and why you're interested maybe. Who wants to start?
We're just introducing ourselves, right? My name is John Humphreys. I work for Texas Instruments. My involvement is getting the TI evaluation platforms SystemReady Devicetree compliant. So, adding the necessary support in U-boot and trying to steer the evolution of the specification that makes sense for the embedded industry.
I am Jagdish Gedia, so I am new to EBBR, so here to understand more about it. So I have a question. So you told, right, it depends on interfaces and not implementation, right? So what kind of interfaces are expected to certify the board EBBR compliant?
Right. So EBBR is primarily about the UFI subset of protocols which are required for an embedded systems. Also about the system hardware description, which is passed by the UFI firmware, such as a Devicetree system table or even a CPI. This being said, there are a few other firmware protocols which are visible from the OS, such as PSCI, for example, which is mandated to bring up secondary cores in an SMP system. And with the recent addition, we have requirements around FFA, which are conditional, in the sense that it says if you implement FFA, then you are required to basically implement version XYZ. But it doesn't mean that you have to implement FFA, but when you do it right, basically. We have a provision around TCG2 EFI protocol to expose a TPM, which is also conditional, saying that if you have a TPM and you expose it, you should expose it in the UFI standard manner, basically. And that's it.
Okay. Okay, so support to, expose these interfaces doesn't go only in bootloader, it can go in the firmware like TFA also, right? For example, PSCI is handled by TFA in some of the cases, or
yes,
like FFA is like at L3, right? So, I mean, it passes through L3 and not through
yes,
the bootloader. So.
Yeah. Okay. But as long as it's visible from the operating system, for the moment we consider that it's related with EBBR as well.
Okay.
Yeah.
Thanks.
So my name is Zhang Yuntian, and I'm from the Rexa, which is ARM single board computer manufacturer. So I'm the system engineers there, and I have been working on the boot chain maintenance, and I have worked on some kind of NixOS upstream for our device support. So on the NixOS, we were able to use the upstream U-boot with the EFI bootloader, and they work fine over there. But for our own system, we have to use the vendor U-boots, and the support there are not really that good. So we are mostly using the standard boot instead of the EFI based routes. And beyond the difference in capability of the vendor U-boot, we also have another issue is that within the current EFI bootloader